I'd like to introduce some new definitions and notation based upon things that we already know. Like here we have this equation y equals negative x plus 4. But also, we could call this a relation. The term relation means you're relating an x to a y, and when you do, and you look at its graph, it gives you a collection of points. So that's what I mean by a relation. You could think of it as this equation, or after you graph it, you could think of it as the picture you get, or the set of points. So what I'd like to do is actually sketch this thing. Maybe I'll use a table of values and put 3 numbers into it and see what we get. So I guess for my x's and y's in my table, I only need 2. Maybe I'll pick 3. It's not really important. I'll say negative 2. Maybe I'll also choose 0 and then 4. Just so I get a couple points so I can graph whatever this equation is. Okay, for negative 2, I put a negative 2 here. The negative is positive 2, plus 4 gives me 6. If I put 0 in place of x, I'm left with just 4. And if I put a positive 4 in place of x, the negative 4 plus this positive 4 becomes 0. And if I graph these points, I get negative 2, 6, 0, 4, and I also chose 4, 0, and I'll draw the line going through these points. This is my relation. It came from this equation relating x's and y's, and it is a set of points, meaning that it has a picture in the xy plane. So I want to talk about a particular type of relation, and it's something called a function. And to get the ball rolling on this idea, I want to introduce something called function notation. So here I wrote y is equal to something in terms of x. Sometimes when this happens, we're going to replace the y with another symbol. Let me write that off to the side. Instead of using a y, I'm going to replace it with the symbol f, a parentheses, and an x. And we're going to read this as f of x. We call this notation here function notation. So this letter f you can think of as standing for function. This is just a parentheses that I open and close, and I put an x in between it. So in this equation, instead of writing a y, I'm going to put the symbol f of x. So if you see f of x is equal to negative x plus 4, we're saying the same thing as y is equal to x plus 4. So that's really important. These two mean the exact same thing. What I'd like to do now is actually practice using this new notation. And what we're going to do is just use these same x values, put them into this notation to see what it looks like. It's going to be the exact same thing that we did from this table. It's just, again, using this new notation here. So if I started with the value negative 2, and I just chose this at random, to plug this number into this formula, it just means you put a negative 2 wherever you see the x. So let's compute that one. We would read this as f of negative 2, and what you do is wherever you see an x, you open a parenthesis, you place in that value and close it, and then you're left simplifying it. So the symbol f of negative 2, that doesn't change. Like this doesn't mean multiply or anything. It's just a symbol that says you put negative 2 in place of x. If you simplify it, we already know the answer is going to be 6, but the negative times the negative is a positive 2, and 2 plus 4 is 6. So the big connection here is if you see this symbol, what this means is x is equal to negative 2 and y is equal to 6. So I'm going to write that right below here. These two things mean the same thing. I read this as if you go over to negative 2 and put that into your function, it takes you up to 6. I'll do this for the remaining 2 points. So what about f of 0? So f of 0 means you go to your function. Wherever you see the x, you put in 0 with some parentheses. No surprise that when you simplify this thing that you get 4. And here we have f of 0 is equal to 4. That's the same thing as the point 0 for x and 4 for y. So again, these two things are the same thing. This means if you go to 0 for x and put that into your function, it gives you 4 back for y. And we could do this for the other point as well. So I might as well just complete that by saying, okay, what about f of 4? That's negative 4 plus 4. That simplifies to 0. We already know this. this is the same thing as the point 4 for x and 0 for y. Meaning, you put 4 into the function, here's 4, and it gave you the y value of 0 back, meaning we have this point right here. So for example 2, I want to do what we did in the first example, where here we have an equation that we're going to graph, but I'm not going to use a table of values. I'm going to strictly use the function notation. In doing so, I want to define a couple of new terms, that is domain and range. The domain is anything that you can put in place of x, so an x value. That's anything on the x-axis. The range is anything that you get back for a y value. So how high or how low does the number go? So again, my goal is to graph this new equation. It's f of x is equal to the absolute value of x minus 5. Now this symbol here just means a y value. So you could really write this as y is equal to the absolute value of x minus 5. I'm going to leave it just as this. To get my graph, I think I'm going to choose maybe 4 or 5 points. Maybe I'll start with x is equal to negative 5. If I put this into the equation, what do I get back? So I'm asking the question, at this x value, what is the corresponding y value? So I'm choosing something in the domain, an x value. I'm going to my function, and I'm putting it in place of x, meaning it goes in place of x everywhere. If there's no confusion with the parentheses, you can include it or not. I don't see like there's an extra negative or multiplication that I have to worry about here, so I'm simply just going to put this negative 5 in place of this x. My goal is to now simplify this. In doing so, we get f of negative 5 is equal to, okay, the absolute value of negative 5 minus 5 more is negative 10, and this changes to positive 10. What this means is, at x is equal to negative 5, the y value is positive 10, I'm going to plot this point. So let's see, maybe I'll choose 0, 5, and 10. So I'll just do this point, and this point. I'm going to choose these x values, which are in the domain, and figure out what y values we get back, which are in the range. So let's look at f of 0. I put 0 in place of every single x. I simplify it. This is the absolute value of negative 5, which is positive 5. This means at x is equal to 0, I get 5 back for y. All right, let's check out positive 5. So I'm going to take that number in the domain, put it in place of all of the x's, and figure out what the corresponding y value in the range is. This is the absolute value of 5 minus 5, which is the absolute value of 0, and the absolute value of 0 is 0. So I see a trend here. I'm thinking that as I'm moving in this direction, the graph is going to go between these 2 points until we got to this spot here. But let's see what happens as we keep continuing in this direction for my x values. So I'm going to choose x equals 10, and we'll stop there. So let's see. F of 10 is the absolute value of 10 minus 5. That's the absolute value of 5, which, since that's already positive, you get 5 back. This says that at x equals 10 in the domain, we get y equals 5 in the range. We could get more points if we weren't certain about what the graph looks like, but I believe that the graph is going through these points until it gets to here, and then it continues in this direction this way. We get like this V-shaped graph. So I'll draw the equation going between those. So here's my graph. It's the absolute value of x minus 5. I encourage you to try some of the values that I didn't pick, like negative 4, negative 3, and maybe 1, 2, and 3, just to see that everything matches up. But really, once you have enough points to get your picture, you can sketch it from that. One other final thought about the domain and the range. This is kind of a tricky thing to determine, but with practice, you can definitely pick it up. The domain of this function is anything on the x-axis where the graph exists. The domain of this function is going to be all real numbers. This means you can pick anything on the x-axis and you always get a portion of the function back. So like here at 7, the graph exists. At 9, we get a point back on the graph. When we talk about the domain, we really mean every single number that you could possibly put in place of x. And if you think about it, you can always put a number in place of x and simplify it and get something back. So I'll jot this down just to say that the domain is all real numbers, or you could just even say all numbers on the x-axis. Now the range is going to be all of the possible y values that you get back. Like how far up and down does this graph go? If you'll notice, the lowest y value here is y is equal to 0. There's never a point where the graph actually drops below the x-axis, like there's nothing down here. This means that you do not get any of these y values going from 0 to negative infinity. They start at 0, the graph moves upwards, so the range is going to be the y value starting at 0 and going up. So I'll say all y's with y greater than or equal to 0. I mean, really, it would probably be okay just to put this as your answer. Like this here is my range. It's all positive or 0 y values, whereas the domain is going to be everything on the x-axis. But really all you need to know is that when I say domain, I mean you're putting something in place of x. And when I say range, I'm saying what number do you get back for y.